Today in this video, we will be talking about how physics applies in Fortnite and how these concepts compare with real-world examples.
To begin, we first have the concept of momentum, which is very prominent in everyday life. Momentum is described as the inertia of motion, meaning the habit of it to remain in motion. Momentum is a vector quality, thus both its direction and magnitude are taken into account. The equation of momentum is P equals m times v, where P represents momentum, m is mass, and v is velocity. Now for our first concept, we demonstrated a change in momentum, otherwise known as an impulse. For this, we used the Fortnite impulse grenade to change the direction of our character. When the character is running, you can see that once in contact with the grenade, the character is propelled backward, henceforth changing both its direction and velocity, consequently resulting in a change in impulse. The second concept we did was an elastic collision. An elastic collision happens as a result of two objects colliding with each other. During the collision, the momentum is conserved and the two objects bounce off one another, resulting in the two objects' velocity reversing directions. To represent this, my partner and I drove two separate golf carts head-on. The end result of the collision was the conservation of momentum as the two carts ricocheted off one another, with their motion continued except in opposite directions. The third concept we presented is potential energy coupled with kinetic energy, which is an outside concept from what we learned in the first semester. Kinetic energy is the energy an object maintains due to its motion. The faster an object moves, the more kinetic energy it has. Potential energy, on the other hand, is the stored energy an object withholds that is based on the position or condition of the said object. Now for our example in Fortnite. In order to portray both potential and kinetic energy, my partner and I placed a shopping cart on top of a large ramp. And at the top of the ramp, the shopping cart and the two characters withheld gravitational potential energy. However, once the characters began their launch down the ramp, that potential energy quickly converted into kinetic energy in the form of motion. Our fourth concept we'll take note of is centripetal force. Centripetal force is an inward-seeking force. It is essential to take into account that centripetal force is a net force that forms due to a culmination of forces such as tension, gravity, or friction. This force is always directed radially inward and is perpendicular to the object's velocity. To illustrate this topic in-game, my partner Ronan entered a vehicle known as a baller. Once inside the baller, he grappled onto a wall and continually rotated around the wall at a constant speed. Thus, when Ronan was rotating around the wall served as the axis and the centripetal force was inward, perpendicular to the tangential velocity.
For the fifth concept, we chose acceleration, and for this, we calculated the change in velocity and the time it takes to reach max velocity for a car in Fortnite. The definition of acceleration as stated by Google is a vehicle's capacity to gain speed within a short time. So this Fortnite car took about 7.88 seconds to reach its max velocity. And as seen in the clip that we played, this car maxed out its velocity at 64 miles per hour, which equates to about 28.6 meters per second. Next, using the equation of acceleration equals change in velocity over time, we plugged in our values, giving 28.6 meters per second over 7.88 seconds. This ended up equating to about 3.63 meters per second squared. Now you know the acceleration of a regular car in Fortnite. We also decided to find the 0 to 60 miles per hour time, and seeing the video, it took about 4.46 seconds for the car to go from 0 to 60 miles per hour, about the same time as a 2001 Chevrolet Corvette C5, which is by far faster than your average sedan. As our sixth concept, we chose friction. Friction is, as stated by the Oxford Dictionary, the resistance that one surface or object encounters when moving over another. To give a real-life example of this, imagine you are on a sled going down a giant hill, and all of a sudden the hill plateaus. You would slide in a straight line until you came to a stop. The reason that you would come to a stop is that friction would be pushing against the sled, making the sled decelerate. Friction is seen almost everywhere in our everyday lives and is in Fortnite as well. For example, in Fortnite, we used a fast car to get to max speed and then decelerate as we took off the gas from the car. The car slowing down represented the force of friction present on the wheels of the Fortnite car, which acted as soon as I let off the gas, decelerating the car to a stop. Terminal velocity is our seventh and final concept that we chose, where we found the terminal velocity of a player in Fortnite. Terminal velocity is the maximum velocity attainable by an object as it falls through a fluid, where air is the most common example. To do this in Fortnite, we first measured the height of a Fortnite wall to be exactly 4 meters. Next, we positioned Nate on top of a giant column of walls to give him time to speed up to terminal velocity over a period of at least 4 walls or 16 meters. Here's the clip. As seen in the video, Nate falls a span of 16 meters at terminal velocity in about 0.38 seconds, and with this data, we can use the equation velocity equals distance over time. Plugging in the values, we got 16 meters over 0.38 seconds, which yielded a terminal velocity of 42.1 meters per second. This value also equates to about 94.2 miles per hour if you're wondering. Compared to Earth's terminal velocity of 120 miles per hour for the average person, the 94.2 miles per hour terminal velocity of Fortnite is a falling velocity that is about 79% of the velocity that you would experience here on Earth from the terminal velocity. Thanks for watching, and we hope you enjoyed the video.